Welcome. Last class, I solved question number. See, I started writing very important basic questions for friction to understand thoroughly. Last class, question 1, question 2, question 3, question 4. Just to understand, question 1 was, see, a rectangular block weighing 30 kilonewton is placed on a rough horizontal surface. See, mu is 0.35 given. And this, don't worry about this h and p by 2. Okay, then a force, right side force P is applied. Find what is the least value of P required to move the block. That means I told, see, don't see here, required to find P when rectangular block is on the verge of moving, because least force means you require either little more than that force. See, answer came 10.5 kilonewton, means 10.5 means it is on the verge of moving. If you remember, the answer came 10.5 kilonewton. If you remember, means 10.5 means it is on the verge of moving. 10.5 means it will move. So theoretically 10.5. Okay, now for that question, no dimensions are given. Or imagine rectangular block, let it be L, length, let it be height. See, three-dimensional. See, length, height and width. See here. This is rectangular block. Length. See, imagine for understanding purpose and later for solution, length is 2.4 meter. Imagine, I am giving it, you write here. Height is 0.8 meter. See, 0.8 meter. Width is 0.65 meter. I have taken this dimension so that your weight will come 30 kilonewton. That's all. And make a note. Imagine it is a concrete block, big concrete without reinforcement. If there is no reinforcement, see, if reinforced concrete in India, we take weight density 25 kilonewton per meter cube. But plain concrete, like pedestal sometimes, concrete bed without reinforcement, plain concrete, usually in India we take 24 kilonewton per meter cube. Therefore, okay, that is the height. Anyway, in the last question, concrete not given, height L not given, only this much given. Okay, now I will first solve the question briefly. See, I will tell what I am telling. See, this is a puzzle class. A puzzle which will test your knowledge or will give thinking capacity for you. See, in the YouTube, in my channel, in playlist, you can see hidden concept, brain teasers or puzzles. I already uploaded 3 classes there. No one has answered properly. One of the question was very critical question. That is for equilibrium, I think. It is very critical. For that one, part B was pending. It was uploaded long back. Now I have decided now to revise all and fresh with more, and that was also systematic only, more clearly I will upload once again. And this question, this puzzle, what I am asking today, I am going to include there. So answer I will not give in this class. I will give there. In separate playlist is there. But hidden concept, brain teasers or puzzles, there I will give the answer. You can answer, when I ask the question here now, puzzle or quiz type, in the comment section, you can write your answer. If answer is good, I will appreciate. Okay, then, okay, leave it now. First do one thing, you make a note here. You solve the last time question once again. See, required to find this, these all already explained in the last class and already over. See, and already over. Already over. Still I am telling because it's a puzzle. See, required to find P when rectangular block is on the verge of moving. Weight is told 30 kilonewton. See, is on the verge of moving, so still not at moved. It is still at rest. It is very important. It is still at rest, but it is on the verge of moving, still not moved. Therefore, I told equilibrium still maintained. Therefore, sigma fx0, sigma fy0 and sigma m0, if applicable, see, if required, okay, I write here, if required, later you require it. See, in so many friction questions later, especially ladder friction all, we consider sigma m equal to 0. All valid, okay, all valid. But of course, last class we used only sigma fx, sigma fy, sigma m0, we are not used it. By the time you applied these two, you got the answer. Okay, now, see here. Consider equilibrium of rectangular block. See, first of all, I should not tell all these things. Last class, first question told, go back. See, let dash dash dash, you write, let R be the normal reaction. And FF limit is the frictional force developed. We are trying to move to right side, frictional force is to left side. How much? It is mu into R, 0.35 into R. Okay, now don't see any dimension. See, I wrote 2.4 meter, 0.8 meter. I am not using it, which was not there last time. Okay, then, short. I will first complete last time question. What you do? You apply sigma Fy0. Okay, see, this basic condition you apply first. What you get? Take upward positive. You get plus R minus 30 equal to 0. Your R will come plus 30 kilonewton. Or, this is quite simple. See, you understand here. See, rectangular block weighing 30 kilonewton, resting here. Downward load, see, frictional force and P, they are all horizontal. So when you consider vertical equilibrium, vertical weight, downward weight of 30 kilonewton, reaction of 30 kilonewton. Correctly tallied. Okay, then. Now make sigma Fx0. Use the second condition. See, interchange, no problem. Sigma Fx0. You take upward positive, you take right side positive. What you get? Plus P minus 0.35 into R equal to 0. Therefore, substitute R equal to 30 plus 30 kilonewton. Right here. Substitute R equal to plus 30 kilonewton. You get P minus 0.35 into 30 equal to 0. Therefore, your P came plus 10.5 kilonewton. Okay, now this is the answer we got. Okay, make a note. This much, see, with this, we closed question number 1. Closed question 1 in the last class. So conclusion is what? The rectangular block is on the verge of moving when the force, applied force reaches how much? 10.5 kilonewton. Means this is the least force. If you apply further more force, it will move. 10.50000001 month, theoretically it will move. Okay. Now, come to the puzzle. To understand the puzzle and later to give solution to the puzzle or that hidden concept or brain teaser, to give answer to that one, I want numericals. So I will take this as L. See, this was not there last time. Height H, width B. Now I will do one thing. I will write in that playlist part also, I will write there. This question was solved in friction chapter, class number, I don't know, lecture number 4, question 1, I will write there. Now, let it be 2.4 meter. See, where is it? Here. Let that, and right here, first of all, now some note right here. Let it be concrete. Let it be plain concrete. Plain concrete of which has got weight density of 24 kilonewton per meter cube. Okay. That is 1 meter cube of concrete weighs 24 kilonewton. See, 2.4 meter. Height I will take 0.8. I adjusted it so that weight will come 30. Width equal to 0.65 this way, which you cannot see here. See, it is this way. See, 2.4, 0.8. This way is, see, 0.75. Find the weight of this block. See, these are all, you should know it. Now, this data, I will do one thing now. I will remove some of the part now. Required find P. Okay. I will remove this one. You write fresh once again. See, this I am not removing. Therefore, write here weight of the block equal to volume multiplied by weight density. This is elementary knowledge. Volume is 2.4 into 0.65 into 0.8, this much meter cube into 24 is in kilonewton per meter cube. Your weight will come. I will calculate the weight now. This question is actually not difficult. I will tell the reason why I am telling this one. So it is how much? 2.4 into 2.4 into 0.65 into 0.8 into 24. 29.952. It will come 29.952, which I have taken. See, it comes to 29.952 kilonewton, but density is not 24. Maybe, right here, maybe density is slightly more, or it is rounded to 30 kilonewton. Now you should not bother how 30 kilonewton came. See, 29.95 kilonewton is 30 kilonewton. That is actually approximately equal to nearly 3 tons. Actually, it is not 3 tons. It is actually 30 divided by 9.81. 3.05 tons. Okay, that is not a problem. 3 tons. 3 tons is 3000 kgs. Okay. Now, this I will remove. That's how we use in the question weight is given. But I told how the weight is calculated. Now, the question is, see, this concrete block is placed on a rough surface. Friction is coefficient is 0.35. Agrees for concrete. See, friction is there. Coefficient of friction is 0.35. How to move this block? We want to, this block has to move, but should not move, should reach on the verge of, it should be on the verge of moving, means equilibrium is still maintained. Sigma fx, sigma fy and sigma m, all three should be 0. Okay. Of course, we are not using sigma m 0. Start now. We got P 10.5 kilonewton. Now you do one thing. See, I will tell you one thing now. One important concept. You should know it. Otherwise, people will tell, sir does not know the concept. Okay. I am explaining or writing the sketches. See, like 99% people will write. You see any textbook, you can see the sketch this way. Sketches. So that means I am writing a sketch, popular way, it is written throughout the world. Maybe X then. And also, I am explaining in the same way as anybody with a good knowledge will explain. But remember, one important, something is going to happen now. Means there is some problem comes here. Some problem comes means there should be some mistake. See, there should be some mistake. That mistake I am committing now. See, that mistake deliberately I am also making. If that mistake is not made, the puzzle does not exist. But where is the mistake I am not telling. That's why, see, I told basic explanation, one sketch, and then all calculation, equilibrium conditions, all the statement I am telling, all this throughout. By after starting solution, when I end finally and ask you, tell the reason. See, why, what is the reason? I will tell. What is wrong? I will ask. I will ask lastly, what is wrong here? What is wrong or what is the mistake? What is the mistake? So when I ask that question, so after starting the class now, little 15 minutes earlier, till I ask this question, in between, a common mistake or some mistake everybody is doing, I am also doing deliberately. Or when I tell some explanation, if there is a mistake in if there is a mistake in the sketch, I am also making mistake in the sketch. If people make mistake in explanation, I am also making that mistake in explanation. If the mistake is in calculation, I am also making that mistake in calculation. Don't tell this 29.5, 30 kN is given, not that mistake. Someone will tell, sir, wait, I have not told the density. So 30 is correct. 30 is, imagine this concrete block is weight. The weight came to be 30. Okay, now the question is, I will tell you question now. See. Okay, now you go back to the sketch. See. Now mark this dimension. Length 2.4 meter. See here. Length 2.4 meter. See, weight 30 will be acting to midpoint. This is correct. It is not wrong. The weight will act centroid or center of gravity, not centroid. Plane area we call centroid. When weight is involved, we call center of gravity. If it is 2.4, it is 1.2. How 1.2? 2.4 divided by 2, 1.2 meter. And height is 0.8. Where you apply that load? Okay, do one thing. You can apply wherever. You make one thing. Imagine that P is applied at mid-height. Mid-height. See, this is not wrong. See, whether you applied at mid-height or apply here, 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 wherever you apply, your answer will come same. Why? We don't consider, see, so far, the distance was not considered. Therefore, you imagine that load is acting, applied through mid-height, P. P is applied to mid-height. Remember, this is not the mistake. Don't tell, sorry, it need not mid-height. No, there is no mistake here. This is correct. See, this is correct statement. If the statement is wrong, there is no meaning for the question. This is correct statement. There is some technical mistake is there. That I want to find. People with the brains or good knowledge, see, I know the answer. I will tell one more hint now. If you go through all the questions solved so far in friction so far, unknowingly to you, but knowingly to me, I have given the answer there. I told you, unknowingly to you, but knowing to me, because if I don't know how I do it, so that mistake I am not committed. Anyway, you don't bother too much now. Okay, now this is right. Now see here. Now you do one thing, enter the value. So how much P you got? See, we got P equal to, now do one thing, make a final entry. Final entry with all the numericals. P equal to 10.5 kilonewton. Calculate frictional force, that is 0.35 into 30, that also equal to 10.5 kilonewton. 1 minute, I check the camera. Okay, correct. See, once you got all the answer, you enter all the answers. See, 30, your R also is 30 kilonewton. See here, solution. R equal to 30 and P, see, 0.35 into 30, mu R, 0.330 also 10.5. So, 10.5 kilonewton horizontal force. See here, 10.5 kilonewton is a horizontal force here, and 30 kilonewton is a vertical force, and here 30 kilonewton is a reaction. Now, my question is sigma fx0, sigma fy0. These are using, right here, using, you first write statement. You solve the question so far using sigma fx0 and sigma fy0. Sigma m0 is not applied, is not used. Not used. See, but even if not used, sigma m equal to 0 should be satisfied. Should be satisfied for equilibrium. For equilibrium. Okay, now start. This, so now write question. Therefore, for equilibrium, write fully correctly here. For equilibrium, sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0 about any point. See, sigma m means about any point. About any point of your choice. So, all should be satisfied. All should be satisfied. Okay, now check it. Okay, I remove this one now. Now check the answer. Check. Start. Sigma fx. Right side, take right side. Right side 10.5 plus 10.5. Then left side 10.5 minus 10.5 equal to 0. Oh, right here. Sigma fx equal to 0 is fully satisfied, right there. Right mark means right fully satisfied. Okay. Then sigma fy. Sigma fy, take upward positive. Plus 30 minus 30 equal to 0. Oh, right here. Oh. Sigma fy equal to 0 is also satisfied. Also satisfied. Now, lastly, if I remove now, check sigma m. I told sigma m any point. Take a point here, A. Take point A. Consider sigma m about A. Any point will do. About A. About A. A. And check about A. Okay. And check 0 comes right here. Right here. About A. Right here. If really in equilibrium, it should be this sigma m about A should be 0. It should be 0. Let us check now. Or now right here. But if you calculate now, right, sigma m about A in clockwise positive, if you take moment about A, see here, 30 into 1.2 clockwise plus 30 into 1.2. Again, minus 30 also into 1.2. Minus 30 also into 1.2. Why? Load down, reaction up. Plus 10.5 into 0.4. 10.5 into 0.4. And one more 10.5 into 0. Plus one more. This is actually that P. This is that friction force. FF into 0. If you calculate, answer is coming 30 into 1.2 minus 31.2. What is this one? 10.5. 10.5 into 4. 10.5 into 4. 42. 42. No, 10.5. 0 missing. 10.5 into 4. 0.4. Oh, sorry, 0.4. I was wondering how. It is plus 4.2 kilonewton meter. That is what? 4.2 kilonewton meter. So right here, I remove this one now. That means what? That means algebraic sum of moment of the entire force system. You write here. You should write algebraic sum of moment of the entire force system about any point. We took any point should be about A. Clockwise positive is 4.2 kilonewton meter clockwise. Oh, it is not zero. It is not zero. How possible? How possible? How possible? What is the mistake? How possible? Right here. What is the mistake? What is the mistake? That is the puzzle. That is the puzzle you have to answer. Or in further simple language, I will tell one more thing now. See, I can tell one more concept. See, 30 down balanced by 30 up balanced. This 10.5 right side and 10.5 left side, see, one right side force of 10.5, one left side force of 10.5, two equal unlike parallel forces will form a couple of any one of the force into height 10.5 into 0.4, a couple of 10.5 into 0.4 equal to how much? 4.2 kilonewton meter clockwise will be developed. That is, this block should rotate by a couple, or that means the given block should rotate due to a clockwise couple of 4.2 kilonewton meter. Then, but how possible? It is in equilibrium. It is in equilibrium. See, 1 minute now. Check. Is it rotating now? Check it now. Check the answer. See now, I will show it. See, see, rotating. It is moving. Or, see, it is on the verge of moving. I am applying a force now. See, move. Where is rotation? Or, you can write, if we look at the sketch, there is an unbalanced couple of 10.5 into 0.4. How it is balanced? It should be balanced. If it is not balanced, see, now I am not writing anything on the board. If it is not balanced, then equilibrium is not maintained. Then complete theory I told is wrong. What all I talked so far about equilibrium earlier, more than 100 questions I solved. Everything gone. And my entire teaching gone, because when I take a subject here or any structural engineering class or professional class, I give lot of importance to equilibrium. So everything I told is wrong. But not wrong. There is a hidden concept. Now you should tell the answer. Come on, think and tell. Okay, that's all I will tell. This furthermore beautifully, I will upload in the separate class. I will upload later. See, already 3 uploaded. One is for Varigno's theorem, proved for concurrent, but applied for coplanar. Second is, when you write UVL, you write kilonewton per meter. Where is that meter? See, UDL, when you tell per meter, you know which meter? Any meter. UVL, where is that meter? Very beautiful question it is. Third one is, if you remember, sigma m0 and sigma v0. Sigma m0 applied twice. What about sigma v0? See there, third question. I am going to give the answer, but so many tried. Some of the people, they gave personal answer to me in the WhatsApp. I told them, no, personal number don't call. See, if you want any clarification on YouTube classes, you should give comments. You should not call me or put comment in my WhatsApp, because see, in YouTube, when I put a demo class for professional class, admission purpose, I display my number there. You can see that number in some of the demo classes. When I start a new course, I publish in YouTube. You can see my number. But I tell seriously, that number is meant only for the people who are joining my classes. Some of them are paid courses. See, everything is free course, but my profession, that is software classes, practical design, it is a paid course, my profession. So, I will tell. So many told, sorry sir. Yes, I told, no, this is not the way to contact me. YouTube, if you want to, about these YouTube classes, if you want any clarification, comment section is there. Comment it there. I will reply it. And so many comments I told, no, nothing doing. So that means today what all I told, there is something seriously wrong or a mistake is committed. I told you deliberately by me. But see, or I made the same mistake which 99% people are doing it, or almost all textbooks you see that mistake is made. All textbooks that mistake is made. So I made the same mistake. Now you find out where is the mistake, how you ensure that sigma m, see sigma m is not this, you can see here, see. Balance. Oh, see here, this will form a couple. How to balance the couple? That's what I want. Now, think and answer. Okay, I told in the title today's class, I'm going to write a puzzle and then back to very important question. Last class 1, 2, 3, 4 over. Today 5 and 6. Now I will upload class now. Now I will go for, I will continue. Don't see this one now. I will continue 5 and 6 question number. Okay, I will continue. Now, come back to, just now I gave the puzzle to you. That puzzle you think and answer. Okay, now, back to last class, I told very important basic questions on friction, question 1 to question 5, and lastly question 6. Remember, question 1, question 2, question 3, question 4, already over in the last class. And based on that question 1, I gave the puzzle to you. See, that puzzle I given based on question 1. That puzzle is valid for every question, all the 6 questions. Okay, then. Now question 5. This is a concept-based question. I will explain the question slowly. See, find the least or minimum, both are same, value of P and also the angle theta. See, last time question 5, where is question 5? Question 4, this angle was 20 degrees. See, I will write here. See, make a note here. In same question, see, in question 4, that angle, that theta was 20 degrees and we got P equal to, I noted the answer there, 9.911 kilonewton. Okay, that was the answer we got in question 4. Leave it. Now, see, first if you remember, when the force is purely horizontal, answer was 10.5 kilonewton. By applying an inclined force at an angle 20 degree last time, the required force came lesser. That means easy to move. That means it is easy to move the block by applying a slightly inclined force, but it should be pulling, not pushing. I will explain all later. Okay, now, answer is 9.911. Now, the person who gave the question thought, when this P is horizontal, you should write all these. P required is 10.5. When you tilted by theta 20 degree last time, it reduced to 9.911. Therefore, maybe at some other angle, least value will come, further lesser will come. That they want. So this time, unknown is right here. Of all the question, now unknowns are P and theta both. But important, remember, P should be minimum. P should be minimum. Least means less than that P is not possible. Okay. Once again, remember, for impending motion, therefore, once again, same story you have to repeat. See, I have not rubbed it. I have adjusted the recording. Puzzle I recorded last, then put in the first. Why? You can see same handwriting. So, required find the least value of P, and also here least value of P, where is the question? And also least value of P, I'll put somewhere here P, and also angle theta to move the rectangular block to right side. Okay. Now, since the question is least value required to move the block means it is on the verge of moving, limiting friction, all the statement will come. Okay, now I will remove all the statements, everything explained for you. See, for sketch required now. Okay, 0.35, okay, I remember. Need sketch required. I will explain the concept of this question. This is little concept based question, not simply an ordinary question. Little what you have to think about the answer or think what they want in the question. See, first of all, free body diagram. See, first. Consider equilibrium of block. Okay, see, put the solid block here. This all I am removing now. I want more space, or maybe I'll put somewhere here, so that space problem is not there. See, this is the block. Okay, surface you show dotted line because why? We are interested in the block. So in free body diagram, weight W acting, how much? 30 kilonewton. Same thing. Oh, sorry. We require also tan theta, 30 kilonewton. Okay, now red color required for friction. Okay, I'll take red color for friction. P over, see, normal reaction R, and see, and force P, angle theta. So later, when you resolve, I should not tell it. Already I told so many times. I told repeatedly, I will not tell. Still, for those who find difficulty, the pencil mark, cos and sine. Angle theta here, this is cos, this is sine, for your information. And frictional force, see, these are the frictional force is acting this way. FF, this light line you have shed it. FF limit equal to 0.35 into R. 1 minute, I'll check the board once, if everything is clear or not. Okay, everything is clear. See, this is the free body. See, 30 Kn and P are action. R and FF are reaction. Okay. Now, this I will remove. I want little more space this time. Little more space required. So this I will remove now. Okay, start. First apply sigma Fx0. See. As usual, mark here. This is XX. This is YY. As usual. Okay. Start. Sigma Fy first. Okay. Sigma Fy first. Anything first will do. But usually I took sigma Fy so far. I won't change it. No problem. Sigma Fy0. Y means sometime for horizontal surface. Sigma Fy0 means sometime easy answer. Okay. Start. Plus R minus 30. See. Plus R minus 30 plus P sin theta equal to 0. So what you get now? You won't get any answer. You will get what? You rearrange it. See, P sin theta plus R equal to 30. You call this as equation number 1. Then sigma Fy equal to Fx equal to 0. Sigma Fx equal to 0. Take right side positive. I will start from P only. Why? Unknown. Plus P cos theta and then see minus 0.35 R equal to 0. Now you can do one thing. From this one, you can write R in terms of P. Therefore, your R equal to P cos theta divided by 0.35. This is R, equation number 2. Because our purpose is to find P, so replace R in terms of P. Now, substitute 2 in 1. What you get? P sin theta plus R P cos theta divided by 0.35 P sin theta plus R is P cos theta by 0.35 equal to 30. Or, see, this is P equal to 30. Or what you can tell? Therefore, you can tell multiply by 0.35 to out. 0.35 P into sin theta, or what you can do is, 1 minute, P cos theta, or okay, 0.35 sin theta plus P cos theta. Oh, not required. You can write as it is. Okay. Therefore, take P outside. P times of sin theta, see, sin theta plus cos theta divided by 0.35 equal to 30. Therefore, your P will become 30, see, 30 divided by sin theta plus cos theta divided by 0.35. This is the equation for P in terms of theta. So, right here, we did not get, so make a note here. Note. See, still we are in all the earlier 4 questions, by this time you get the value of P because theta is known. But unfortunately here, we did not get the answer. Our P came in terms of theta. Okay, now one important observation. Make a note. See, if you see question number 1, your theta is 0 degrees. Then P equal to 30, see here, 30, question 1 and question 2, 30, question 1 only take by, it is a pulling force, okay, 30 divided by sin 0 is 0 plus cos 0 plus 1 by 0.35. 10.5 kilonewton. Yes. If you remember, we got answer 10.5. In, see, question 3 you can't apply because question 3 is a pushing force. Question 4, make a note. Same question given where theta was given 20 degrees. So if you substitute theta 20 degree here, sin 20 plus cos 20 divided by 0.35 reciprocal into 30. Answer is 9.911. Oh, yes, see, answer is tally. But unfortunately or fortunately, fortunately because concept, here theta is not known. Now, how to find theta? So now, see, I will, very important, this all I will remove now. How to find theta on P. Now make a note. So make a note now. Now, no more equilibrium conditions are available. Conditions are available. That's all. Therefore, how to get P and theta both? Problem, only one equation is there. You cannot get, we got P in terms of theta. Therefore, use the mathematical concept. Go for mathematics. See, mathematical knowledge. Here, you should write all this. P is unique value. Unique, or it is the least or minimum. It is a minimum force, see, as per the question. As per the question, your P is the minimum force. Therefore, go for mathematics. I write here now. We know that, see, right here. We know that. I will tell sometime in the offline class. Knowing or not knowing. I am telling you, believe it. They will tell, yes, sir, we believe. Okay. Now, we have right here by mathematics. Don't write in the examination mathematics all. You write we have or we know that. Knowing or not knowing. For P to be minimum, differentiation of P with respect to variable. What is the variable here? Theta. With respect to theta, d theta should be equal to 0. This is mathematics. See, for a function to be maximum or minimum, its derivative with respect to the variable should be will be always 0. See, when you differentiate for y to be, suppose y is a function of x, for y to be either maximum, either maximum or minimum, dy by dx should be 0. Here instead of y, p is there, instead of x, theta is there. So we want to find least minimum p. Variable is theta. Differentiation of p, I am seeing the light color for the theta equation there. Okay, visible. Differentiation of p with respect to theta should be 0. Write that condition. Okay. Now I will tell you one thing. I know the answer. That theta, this is a secret. See, secret. Don't tell anybody. Secret. That theta should be tan inverse of mu. I know it. I know it because lot of concept is known for me. You don't ask how you know it, sir. I know by concept only. Okay, leave it. You don't know it. Okay, start. Start now. Therefore, what you do? Differentiating P with respect to theta and equating to 0, that is dp by d theta, you make equal to 0, we get dp by d theta equal to, some ink is very light. I had put some ink, 1 minute. Very light it is. Little ink required. 1 minute. Okay. 1 minute. Had doubt whether recording on or not. I'll check once again. Recording on. Okay. So differentiate P. This is a new concept. Remember, this is required in structural engineering. So dP by d theta equal to, see, denominator. See, differentiation is denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. If you don't know, learn it now. I can't write here. So first denominator, sin theta plus cos theta divided by 0.35 is the denominator into differentiation of numerator, 30 is a constant, into 0 minus numerator 30 into differentiation of denominator. Differentiation of denominator is sin theta becomes cos theta minus y. Cos theta becomes sin theta and divided by 0.35. This much basic mathematics required. Divided by sin theta plus cos theta divided by 0.35 whole square should be 0. If it is not visible, I write once again here. See, light color, now dark color, 30 plus P equal to, because earlier ink was fade, sin theta plus cos theta by 0.35. Okay. See, denominator into differentiation of numerator 0 minus numerator into differentiation of denominator divided by denominator square equal to 0. Now, see, when something is 0, remember, denominator cannot be 0. You can cut it. It's a rule. Denominator cannot be 0. Or you take that side. Why? If denominator is 0, it becomes infinity. So only possibility is, this is already 0. So you get 30 even. 30, so minus 30 into cos theta minus sin theta divided by 0.35 equal to 0. This is a constant, you can cut the constant, take that side. Or therefore cos theta equal to sin theta divided by 0.35 or sin theta divided by cos theta, see, sin theta divided by cos theta equal to 0.35. Therefore, I will use red color now. This is nothing but tan theta, see, that is what? Sin by cos is tan. Tan theta equal to 0.35. Therefore, what you can tell? Therefore, you can write theta equal to tan inverse of 0.35. For this value of theta, the force required is the least force. If you remember, I already told, I know the answer. See, I told theta should come tan inverse mu. In this question, mu is 0.35. Oh, yes, correct. Someone should tell. Oh, this person at least knows something. Okay, done. So angle is now accuracy. I will put a little more accuracy. Tan theta is 0.35. So shift tan inverse shift sin inverse 0.5, 30 degree. Yes, correct. I am checking for degrees. Shift tan inverse 0.35. The angle is 19.29005 degrees. See, very nearly 20 degrees. Therefore, your theta equal to 19 point, little more accuracy, 19.29. Actually, 29 is sufficient. 29 for more accuracy, 005. Okay, 005 degrees. This is the theta. Right here. For this value of theta, P is least possible. Now what you do? Once you get theta, okay, everything is over now. Right here. Substituting, continue, last. Substituting, continue from here. Substituting, your P equal to, see, P equal to 30 divided by, why I don't know, when I don't want green, green will come. 30 divided by sine of 19.29005 plus cos of 19.0029 cos of 19.29005 divided by 0.35. Therefore, you get the value of P. P will come in kilonewton. It has to come less than 9.911. Why? And when theta is 20 degrees, it is 9.911. This is supposed to be the least value. So it has to come less than 9.911. Okay, start. Sine of how much? 19.29005 plus cos of 19.29005 close divided by 0.35. It is reciprocal into 30. 9.911 comes actually 9.9105. See, 9.9105. 9.9105 kilonewton is the answer. Actually 9.91, where is the answer? 9.91051274 not required. Anyway, see, when theta is 20 degrees, it was 9.911. Little lesser, 9.9105 kilonewton. Therefore, you write a note here, for the given rectangular block weighing 30 kilonewton, resting on a surface, rough surface, with the coefficient of friction 0.35, the least effort required or easiest way to move it is apply a force of how much? 9.9105 kilonewton, and it should be applied at an angle, pulling force, a pulling force of 9.9105 kilonewton with horizontal at an angle of little less than 20 degrees. 19.29005 degrees is the answer. Okay. This question is over. Now I will go to question number 6 where the more concept is there. Okay. Okay. Now I told next is question number 6. But before question 6, some important discussions for those who are serious. Consider question 1, question 2, question 3, question 4. For all mu equal to 0.35 and all are right here limiting cases. Right here. All of them are limiting cases. All are limiting. Okay, other problem, nothing to worry. All are limiting cases. Question 1 is a horizontal push required. Answer came 10. See, red color is the answer we got. Answer came 10.5. Normal reaction we got 30. Frictional force we got 10.5. One more, each balances. Question 2 is a pulling force. Again, horizontal pulling force. Same answer came. I will tell you now. See, that is, suppose there is a car. See here. Either you go to back side and horizontally push, or go to front side, put a rope and horizontally pull. Both are same effect because it has no vertical component. As long as you apply pure horizontal, push or pull does not matter. But 3 and 4 are inclined forces. P is inclined push. 3. 4 is inclined pull. See, suppose there is a car. I shall show you here. See, I will show you here. Suppose there is a car. 2 wheels I will show here. Okay, sufficient, this much car. You go here and push this way. Or this is the case of a car. See, some wheels are required. Okay, don't worry too much about those things. You go and pull a rope and apply a pull. See what happens. When you see the car weight is already acting here. Car weight is already acting here. And remember, every time frictional force limit is 0.35 into R. Into R. See? R is normal reaction. R. Here also see, this is weight is how much, as our case, 30 kilonewton, okay, 30 kilonewton, car weight, 30 kilonewton. And see, normal reaction R, frictional force is, FF is, okay, red color, FF is 0.35 R. R, okay, I'll put R also red color. Okay, I'll put R also red color. Okay, then P. Okay, P, here, you are apply inclined push. What will happen here is, see here, when you apply a force, it will have a horizontal component like this and vertical component like this. Horizontal component is responsible to move the car. The vertical component will press the car down. See, if you push this way, it will press the car down. When it presses the car down, car will fit more, what it will correct, go and what? Press the soil or road. Therefore, the pressing effect on the road is more. That's why more reaction came. How much came? See, earlier it is 30, it increased to 34.380. When you press, see, suppose you take something, press on the ground and push it, effort required is more. That's why your P value came how much? 12.033 kilonewton. That is more effort required. If you apply an inclined push, unknowingly your inclined push has got a vertical component which will further press the block down. So it will have what? Tightly fit to the surface. So friction becomes more. See, earlier friction was 10.5. Now see friction See, if you substitute friction force, it will come 12.033 if you substitute. But when you apply force this way, suppose you pull a cable and pull the car this way, then your pulling force will have a horizontal component this way and vertical component this way. Horizontal component is responsible for moving the car. Vertical component will actually slightly lift the car. When the car is lifted, means it will try to lose contact with the ground, or this weight 30 is there. Slightly lifted means net force transferred to the road becomes lesser. So your normal reaction came lesser. See, 26.610. See, you earlier 30, this way increased, this way decreased. See, if you pull the car inclined way, this way, unknowingly you are pulling the car and also slightly lifting the car. When you slightly lift, what happens? The friction becomes lesser because it won't tightly fit now. See here, when you apply force push, it will tightly fit to the road. Now here, this force will try to slightly lift it. So when you try to lift it, relieve it, friction becomes lesser. That's why your P came lesser. How much? 9.911 kilonewton. Therefore, remember, suppose there is a car. You want to tow the car. See, pure horizontal you can't apply. So usually cars are pulled. The pulling should not be horizontal. It should be little inclined. If 20 degree means what is the answer? You got 9.91. One unique angle. See, 19.29 something we got there. There, effort required came further lesser. So one particular angle, it is very easy to move the car. For this question, it is theta is 19 point something. Question 5, answer of P I don't remember. 9.905 something. I forgot the answer now. Who will remember the answer now? Some answer is there. See there. That is the least. So therefore, suppose that a car is on the road. You have to tow the car. What to do? You put a rope, connect to the bonnet or front portion. See here. Put a rope. See that the rope is inclined with horizontal, not 20 degrees. At that theta we got last time, 19 for this. When mu is 0.35, it will change with this, depends upon mu. See, you can't go and take the mu value in the road. Anyway, at little inclined, see, for this question, if this is the car, easiest way to move the car is tie a cable at an angle of 19.29 something you got last time. Effort required is 9.90, 20 degree also is okay, 9.91. Whereas, suppose you go from back side and push it, your push will press the car more into ground, effort required is more. These are all concepts you should know or understand. So all this what I told is meant for those who are interested in the concept. Okay, now I will go to question number 6. Question 6, remember, this is a very rare question, but important for competitive examination, where such questions are given. For the rectangular block shown in figure, see, weight 30 kilonewton, same as last time. An inclined pulling force, they told inclined pulling force of 6 kN is applied as shown in figure, as shown. See, at 20 degrees. Mu is 0.35. Find reactions on the block. Now, little later, when you consider equilibrium, I will tell what mistake you will make right there. When we consider, see right here, question is, see, there is no finding unknown. There is no finding P. P is given. So, find reactions on the block. Now, right here, what mistake people will make in this question is, I will tell you. Usually, you make a note here. See, this all I will tell later. I will first tell the mistake people will make. They will mark 30 kN, normal reaction R, 6 they will put away. They will put FF this way. Okay. Then they will put in a hurry FF equal to mu R. See, mu R equal to mu 0.35 into R. Okay, they will write this way. This is, I am telling, what mistake people will make. You should not make the mistake. Then they will start applying. See, sigma Fy equal to 0. Okay, start. Plus R minus 30, see here, plus 6 sine 20 equal to 0. See, plus R minus 30 plus 6 sine 20, 0. They will get R equal to, see what they will get, R. 30, see, 30 minus 6 into sine 20. 27.948 plus 27.948 kilonewton. Okay, they will get R. Then they will make, correct answer, see, 1 nimisha, 27.948 minus 30 minus 6 into sine 20 equal to 0. No, 27.948 minus 30 plus 6 into sine 20 is 0. Okay, now next they will make sigma fx 0. Right side positive. They will write plus 6 cos 20 minus 0.35 R equal to 0. They will write that way. Therefore, substituting 6 cos 20 minus 0.35 into R, 27.948 equal to 0. Then suddenly, what is this? 6 into cos 20 is something, okay, minus 0.35 into 27.948 is minus 4.144 equal to 0. What is this? Where is the unknown here? What is happening here? See, nonsense will come. Because this is not the limiting friction. They randomly give that 0.35 they given just to confuse you. Okay, mu is there. That 0.35 is only for confusion they given, just to confuse you. Or they can give horizontal force also. If they give horizontal force, further beautiful question. If they give horizontal force, question becomes further more beautiful. They will get very easily. Then, see, over. Answer will not come. The mistake is that they will take FF equal to mu R. FF, they won't limit. So, FF limit equal to mu R is only when the block is on the verge of moving. Nothing given in the question. This is simply resting on the ground, somebody applying a force. Or make a note. It is like a car parked in the road with the brakes of not front brake on, rough surface. Somebody puts a rope and pulls it by a force of 6 kilonewton. He is not able to move the car. He is pulling it. See, friction will come. When they try to pull, friction will come, but not limiting. Some random force. A strong person can apply high force. A child can apply lesser force. So therefore, this question, your FF developed is not mu R. So now write class, not limiting. See, this is a wrong solution right here. This is what we have done here is a wrong solution right here. Because this is not limiting. Now come back here. Note, class. This is not limiting case. Nothing given. FF developed is not equal to mu R. Instead, FF developed we have to find. Because, see, in the question, they asked what? See, in the question, they asked what? See there? They asked, find the reactions on the block. So, consider this question as an ordinary reaction calculation question. Over. So, write the statement here. So, when the block is resting on the ground, see, let R be normal reaction. normal reaction on the block, and let you write FF, that's all. Don't put F, simply frictional force, FF, be reaction. See, friction also is reaction. Horizontal reaction, be reacting or resisting. Reacting or resisting frictional force on the block. None of them, and remember, by mistake also, do not write FF equal to mu R. It is nonsense. Now put the sketch here. See how easy to solve. Now put the sketch. Now write, consider equilibrium of the block. Weight 30 kilonewton right here. Now I won't solve it now. See, normal reaction R. You are applying a force of 6 kilonewtons here. See, there is no unknown here. 20-degree angle. Since you are applying a force to right side, the tendency is to move to right side, right here. Frictional force is to left side. So now your R, I'll put green color, R and FF are the unknown reactions. So therefore, start. Sigma Fy0, what you get? Plus R minus 30 plus 6 sine 20 equal to 0. Solve, let it be equation number. You simplify it. Okay, simplify it. Therefore, you get what? Therefore, R, you get the answer. You get the answer directly. Therefore, R will come. Value of R only will come. Okay, no equation. Your value of R will come. Okay, calculate. How much it is? 30 minus 6 into sine 20. 27.948. R equal to 27 plus 27.948 kilonewton. Okay, now sigma Fx equal to 0. Take right, this upward positive, right side positive. What do you get? Minus FF plus 6 cos 20 equal to 0. Therefore, you get the value of FF. See, FF 6 into cos 20 is 5.638 kilonewton plus 5.638 kilonewton. Therefore, write the final answer. What? When the given block is resting on a surface, don't tell that mu value. Then, if the block is still stationary, it is their problem. If the block is moving, we are not responsible. Understood that this block is stationary. There is no requirement of reaching limiting stage, nothing. Then there is a normal reaction of 27.948 kilonewton vertically up on the block and a reacting frictional force of 5.638 kilonewton acting to left side. This is the final answer. Remember, therefore, last I will tell that's all. Now onwards, 99% of further question will be limiting only. See, this is a rare question, very rarest of rare question. Now onwards, when I solve, almost 99% limiting question only. Rarely, once in a while, I may put this type of question. So, therefore, unless it is told, see, or you can make out. If they give P here, yes, I agree. Suppose the value of P given here, then you cannot find P. Understood that the purpose of P is to move the block even if it is not given. But here, randomly applied force is not limiting. It is a random force. So now R and FF you take independent. Remember, make a note. They are not connected. They are not connected. Both are independent. Both are independent. You write there. Hope the concept is clear. Okay, now everything is over. Now we'll meet in the next class. What puzzle I told in the beginning of class, you think and write the answer in the comment section. Very easy answer, not difficult. Okay, thank you.